What if you have a lot of data and you just don't know what to do with it? What if you need to figure that out? You have the smart people on your team. That's where machine learning comes in. Today we're going to talk to a real company with real data doing real benefits for people using machine learning and classical analysis against a data set that's so big there's no other way to do it. Stay tuned. And welcome to the next episode of Microsoft Dev Radio. I'm Jerry Nixon, and I'm here at the Atlanta Microsoft Innovation Center. Pretty cool place to record, and I'm talking to none other than Robert Ortega. He's the CTO of BTT Corp. Robert, thanks for being on the show.
Thank you for having me.
We are also just couldn't be happier to be here with Young and with David Crook and Yun Chou. Hey guys, both on the evangelism team like I am, and they've been working with Robert to build something that is pretty amazing, and I can't wait to show you guys what it's going to be. And Robert, let's start with you just so we can get a feel for who are you and who is BTT?
I'm Robert Ortega. I'm the Chief Technology Officer at Tunnelgenix Technologies, which is a medtech company concentrating on devices as well as artificial intelligence to help manage a number of conditions like sleep disorders, multiple sclerosis, and conditions such as the ones that I mentioned.
Okay. And Young, tell me a little bit about the project.
Yeah, the project actually is it's pretty interesting. It's taking the temperature from our brain and through they call it the brain thermal tunnel, and then take that measurement and then pump it into some training model and into Azure machine learning and try to figure out what's going on with there. And on that part, David did a great job to come up with this whole architecture and the solutions. David, you want to talk about that?
Sure. So when we got in there was quite a bit of stuff already rolling. So Robert and his team already had a lot of the IoT portions done. So what we took a closer look at was actually enabling the machine learning capability, specifically pattern recognition. And something kind of interesting was that we started treating the brain temperature kind of like a signal as opposed to just static points and temperatures at points in time, which allowed us to use kind of classical signal processing techniques. And we would build those models on our own workstations, download from SQL Server. And the wonderful thing about Azure Machine Learning is as long as you kind of stick within a couple of known paths, it's very easy to operationalize those models inside of it and create production applications. So kind of the flow was to bring data from SQL Server, train it on our workstations, and then push it back into Azure to integrate into the production system.
Cool. All right, so take me to the early part of the process here. So here I am, it's just my body, and somehow you measure what type of device or are you using?
Sure, Jerry. I don't have a device with me, but what we use is a sensor that touches the external terminal of the brain thermal tunnel, which is located around here on either side of your nose. Okay. And using this sensor, we capture in a non-invasive way and in a continuous way the temperature of the brain, which is then transmitted to the cloud. Specifically, we transmit it to an IoT hub.
Okay.
From there, we do all of the other processing.
What I like to think of it like a computer kind of crunching numbers. If you think about it, it's kind of like a heat exchanger in your brain. And just like the out fan on your computer, when you start thinking too hard, this starts pushing that temperature out, and you can see it just start cranking up. So it's kind of like they got the bright idea, hey, it's a heat exchanger, let's stick a thermometer on it. And the amazing insights that you can get out of it are just phenomenal.
So Robert, the BTT has figured out that a certain temperature means something, and a certain change in temperature means something as well. And if you can find, if the temperature is this, changing to that, and then going to this, that might mean something as well to be able to diagnose and help patients?
That's what we're working on. basically by using the patterns of temperatures that we capture from the brain thermal tunnel, we are working to develop detection to identify conditions and also to be able to treat the conditions in the future by applying techniques like thermomodulation.
So tell me, Young, I take the data, I put it up in SQL Server, and now you're going to use Azure ML to do the processing. Tell me a little bit about the models.
Yeah, I think what's really interesting about this project is they take temperature from the brain, right? And then through the measurement, and actually a thermal tunnel kind of through the bridge of your nose. And once they take that temperature, And so we took it and we downloaded it to our local workstation. We pump it into the actual machine learning model. And I actually did several experiments of it to try to different variation. And eventually used the training model that David developed, we were able to really get the results that we're pretty exciting about. So after we went through this experiment on Azure Machine Learning, then David kind of converted into a production model and actually allowed BTT to use it to really do some pretty exciting experiments.
David, as you were working on the models, as you were processing the data, was anything surprising?
Yeah, when I first started on it, I had just got done reading a book on like neural networks. Neural networks are like the thing. It's like cool. It's all the thing the cool kids do. And then I get in there. It's like, oh crap! You need like a couple million examples to actually make a neural network work. So I was like, I can't do this anymore. So
yeah.
I went in there. I was like, I just read the book on this really cool thing, and surprise, you're not allowed to use it because it doesn't work in this scenario. So that was kind of the big surprise to me, was that the latest and greatest cutting edge technology does not necessarily always work in all scenarios. So we actually kind of went back to some earlier known techniques. The one that we pushed out was a decision forest, and that was kind of surprising to me because it's kind of just like it's like a tree, like multiple trees, and you make different decisions. If it's greater than this, then that, and if it's less than this, then that, and that's kind of how it goes about deciding what pattern it's actually seeing. And then you have a model that kind of converges on what those values should be in there and what the structure of the tree looks like. And it was just kind of surprising that we went all the way back to one of those techniques, and that was actually the most effective. Because you really don't know what's going to work the best until you just do it and just see what results you get.
Yeah. And now I heard you say it went into SQL Server, and why SQL Server as your database?
Well, one, it was already there, so Robert and them already had the ingestion going through SQL, and when we looked at it, it was handling the load perfectly fine for the devices connected to it. So traditionally, folks are throwing their data into Hadoop or some other large data storage system because really they didn't really have a test.
Because they think they have big data, right? That's where they are, and so they use a big data database.
Yeah,
but their data's not always big.
And even if it is big, SQL Server just like ate it like it was nothing. It was just, so that was another really big surprise. Was I'm sitting here thinking, all right, we're gonna have to put it into blob storage. It's gonna have to be HDFS compliant and all these kinds of things, and that just wasn't the case. SQL Server was just like, here's your data, go. And once we were done with that, getting the data out, training it wasn't too bad because we could use whatever infrastructure we wanted. And then once you've trained the model and you can stick it up in Azure Machine Learning, Azure Machine Learning is kind of like a stateless web service kind of thing. So it doesn't really matter that much about the complications there. So like the most time that you spend is in the training of the model, not the execution of the model.
Sure.
So you don't need super infrastructure there either. The only place you need super infrastructure is ingestion and training. And in this case, you didn't really need that crazy of infrastructure for either of those things. So
nice.
You got to get away with just run-of-the-mill stuff.
Now, Robert, this model that we have now is starting to do some prediction. It's early on. This is a young model, really. What do you kind of hope? What have you what have you seen so far? Has it been able to deliver at your expectation? And then what do you hope happens in the future?
I think the model has been excellent. For me, one of the most important things is that the model depicts a framework and a way of framing the problem that we can apply not only to this particular pattern that we were looking at, which is the arousal pattern for sleep, but we can apply a similar model for other type of conditions that we're trying to detect. So as a first step, I am very pleased and satisfied with what was done, and now we are growing that into other areas. So the performance has been very good. One of the things I like to highlight is how easy it is to try out the model by invoking it directly from Excel, for example. Oh. And it's just so easy to see the results and to try this thing out, as well as just having the sample code that you can take and immediately use from C# or from R or Python to be able to do the invocation part of the model.
Yeah, because now what you're finding are trends, what you're finding are indicators, what you're finding are things that match other expectations, things that with that much data, a human isn't going to be able to do it. I mean, there's so much value in Azure ML or just machine learning in general to be able to make something valuable out of this massive data. I'm glad you said that because I think a lot of people forget that you can't just put it in a graph in Excel and look for a trend. Sometimes these trends have so many different factors, so many different features that you're looking at that the human brain just really is going to be able to miss most of them.
Yeah, it took kind of the way I was looking at it was to take Dr. Abreu's brain and digitize it so that it can find these issues. Like right now, take somebody like Dr. Abreu or Robert to be able to identify these patterns. And if you can teach a computer to identify these patterns, you've suddenly democratized the insights into your brain. And that's kind of, I think, the really interesting goal that BTT is pursuing, is that if they are successful with this technology and actually getting this out into the world, insights into your brain is just going to be something that future generations are going to take for granted. It's going to be, oh, we put this device on. Oh, you have Alzheimer's, or you're going to have Alzheimer's 20 years from now.
I don't want to put that device on.
Yeah, well, you're definitely going to have Alzheimer's, Jerry.
Great. Thanks, David. My new favorite guest.
Talking about that, I would like to hear from Robert that what's the application of this model and the device you guys are developing? And this, I really would like to know what's your vision in terms of where can we apply all this technology and those experiments that you guys have developed.
Yeah, one of the things that we're building is a sleep service, and we'll be offering a subscription service to help you manage your sleep. So one of the things that we will do with the work that you guys have helped us advance is to be able to detect when someone has woken up. Mm-hmm. So if we detect that this pattern occurs several times during the evening, we'll be able to have a measure of the quality of sleep of someone. So that's just a simple application of the framework that you guys helped us with. Then from there, we will extend it to offer protection in a number of other areas. For example, we'll be able to detect if someone is suffering from hyperthermia or hypothermia in the evening, or if somebody's having an infection. But overall, the same approach that you guys have helped us frame is what we will use in the future to detect and to prevent and to basically raise alerts for any one of these conditions.
Hey, Robert, can you expand on the impact? Because that was one of the things that amazed me the most was the actual impact that this has on sleep. Like, why sleep?
Sleep is an excellent way for us to start because many things happen while someone is asleep. And the idea for us is to really offer an entry point service where we will start by helping someone understand their sleep and by offering a level of protection while they are asleep. And then from there, we can offer other add-on services, for example, to be able to detect infections, let's say. So sleep is really, really good as an entry point for us to do that. And there are so many issues that are associated with sleep, and the consequences of sleep deprivation are so severe, including things like high number of accidents. If you check any of the statistics, you will see how many situations have to do with poor sleep or sleep deprivation. And interestingly enough, many people that are sleep deprived are not aware that they are sleep deprived. So we hope to bring to light some of these conditions so that people can take action and help improve their quality of their lives.
Yeah, that's great. I think it's beautiful to me to see technology finally unlocking these doors that have been locked for so long, where smart people like you, Robert, come up with really great ideas that, without some sort of technology boost, there really would have been no way to take that data and make something out of it, and and like you said, David, democratize it so that it's available to everybody in a way that maybe is affordable, and rather than a gigantic research project per person, and be able to use machine learning as well as IoT Hub and all of these pieces, how they all fit together, and create a system that. How long did it take to put together this project?
So they already had a lot of the pieces in motion, and a lot of this is actually based on research that Dr. Abreu did at Yale and on his own. So, if you discount the 20 years of biological research and patents and all that was already done, we just kind of talk about the parts where we take that research and try to productionize it. Our portion of the project was about 2 to 3 weeks where Young and I were hands-on coding, and then Robert and BTT had already had a solution in motion before we had arrived. So I am not entirely sure how long that took. I don't know, Robert, how long were you guys working on it before we got there?
We have worked on it for about 4 months because
It's amazing.
one of the key components for us is the actual application that captures the signal. And then it's not just the application running on a computer or on a mobile device, it's actually the firmware and the software that runs on the devices that interacts with the sensor.
Sure.
So about 4 months before Microsoft came on to help us, frame the problem and do, basically help us build a reference case for the machine learning part.
Okay.
Jerry, I think the really, from technology point of view, the excitement of this project is they have done a study, right? And all this IoT, the machine learning, just technology become available these last couple of years. And with the training model that David developed and with the data collection we have collected, we were able to really develop the model in Azure machine learning very quickly. And with all those mathematical model and statistical model that's readily available for us, we were able to really kind of set it up, experiment very quickly. And I think, if not too long ago, this could be easily months, if not years project to really go through so many experiments and to come up with the conclusion of it. So I think from technical point of view, personally, I think it's very exciting. You see the technology, the science, and all the passion all blended together and come up with this project.
Yeah, I'm right there with you. And what's amazing to me is just you guys have made it sound like 6 months. You could have said 6 years. It would have been just as amazing if you really think about what you're able to do. And just think of the future, how small an investment will be to bring in more information, make bigger kind of diagnoses from them as well. Pretty incredible. Young, if a developer or an entrepreneur is watching this and they're wondering how they might be able to get started, where would you point them?
I would say, you really need to spend some time, look into like the machine learning, take advantage of that. Well, I'm a Microsoft employee, so the Microsoft have a lot of really readily available solutions for you to experiment. We really need to take time to look into that such that you can focus on your energy on really the science, the interpretation, the data of it, rather than do the infrastructure, plugging cables and doing things like that. So all that been taken care of. What we need to know is the capability of it. So focus on your study and then take advantage of what all this technology company like Microsoft can provide you.
Makes sense to me. David, point a developer anywhere?
I think the best thing to do would be, if you take a look at this particular project, some of the things that were the most groundbreaking was the availability of IoT Hub, Stream Analytics, SQL Server, and Azure Machine Learning. If you can learn and understand those 4 components, you can quickly develop almost any IoT project of your dreams. It's just really phenomenal what those, the combination of those 4 products brings to bear, because you basically have infinitely scalable message passing that can be analyzed at real time and develop advanced predictive models like pattern recognition. So, maybe not pattern recognition for you. Maybe you're monitoring oil and gas pipelines. Maybe you're developing the next smart building. The architecture there is exactly the same, and there's a reference architecture on the Microsoft IoT Suite's website. So if I were a enterprising entrepreneur, that's exactly where I would go to begin looking for reference architecture on how to design solutions very quickly so that you can get them in market, because that's really what's the most impactful about this, is being able to take ideas and concepts in research and transform those into product that you can actually bring to the world in very short timelines with very small teams.
Yeah, that's right. Robert, thank you for the work that you're doing, and congratulations on this project and what's coming next. Thanks for being on the show, guys. We learned a lot.
Thank you very much. Nice to meet you.
Jerry.
We'll see you again.